Hi, this is Professor Scott Norman, aka Professor Pintane. Today we are in the Pittsburgh State University Maine's Automotive Lab, and we're talking about airflow through the HVAC system in an automobile. One of the things that I have realized over the years of teaching is that students have a hard time understanding airflow under the dash through what we call the HVAC system, the heating, ventilation, air conditioning system, or the air management system under the dash. It's something that they don't see. You know, they're normally used to a compressor, they kind of know what that is, and they understand a little bit about refrigerants. But when you start talking about things under the dash, most of them have not done anything under there. Maybe a blower motor replacement, maybe a blower motor resistor replacement. But as you start looking at HVAC systems on modern cars over the last 30 years, the airflow through them is relatively similar to most vehicles. One of the things that we do in our climate systems class is I have the students physically take one of these HVAC assemblies apart, and I got lots of them through, you know, the vehicles that we scrap out around here, the actual donation vehicles that we get. Students will go in and pull HVAC assemblies out and then take them apart, you know, get experience replacing an evaporator or something like that. When we start looking at our airflow, this HVAC assembly is kind of positioned under the dash. You don't normally see it. Over here on this side is kind of where the passenger's feet would be in the car. I would be sitting over here on the driver's side, so you know this section right here would be maybe in the very center of the dash. Maybe the radio or something like that would be somewhere right here in this area right here. And so typically airflow starts over here in what we call the inlet door, or the inlet section of the HVAC assemblies. You can kind of separate it out into three sections, but this is the inlet section. And we have an inlet door that has two positions. And so right now I can see that this door is closed in this position, but it's open to the top. And so that top position is where fresh air is coming into the cabin. So if I take a look at my HVAC assembly over here, I have a recirc button. So if I had that recirc button off, it would be on fresh air. And most systems will default to fresh air. You want fresh air going into your vehicle to create a slight positive pressure. It helps keep door seals sealed, especially if you have like a convertible top or something like that. If I hit my recirculation button, this door is going to move up. And at that point, airflow is going to come in from inside the vehicle, kind of by where the feet are at on the passenger side of the vehicle on that. And so that has two positions. And you have an actuator over here that is controlling that. Most modern systems have an electronic actuator. So here's an example of electronic actuator. This is a two-wire unit. It's a motor, it's an electrical motor controlled by maybe a body controller, maybe the actual climate control system itself. But I could put positive and negative on one side of these wires, or I could reverse polarity and move that motor wherever I want to. And these motors are nothing more than, I got one torn apart here. You have a very simple DC electric motor with a whole bunch of gears in it for gear reduction. And so not real complex system. The actuators do have a lot of problems, and they do get replaced because they are a mechanical system, but you shouldn't be able to move it or anything like that. You know, it's very hard with all that gear reduction. So once the airflow goes through the inlet door, or sometimes called the recirculation door, then we have the blower motor here at the bottom. And blower motors, you know, this blower motor sits up here underneath like that, but blower motors have you know, been the same for 40 years as far as what they physically look like. Now some of the electronics have changed with some of the newer brushless blower motors, but really, you know, you got this squirrel cage. I think of it more as a hamster wheel is what it looks like versus a squirrel cage, but a very, you know, very simple device as far as a DC motor on that. 3 bolts, typically 4 bolts, you know, you pop it down from the bottom, kind of where, again, your feet are at on the passenger side. And what controls this blower motor? Speed. You know, if I take a look at this system right here, this is a manual AC system. I only have 4 speeds, so if I only have 4 speeds, it's probably an older style blower motor resistor, and so this is an old-fashioned wire wound blower motor resistor that is also up under there, and the blower motor would actually be plugged right into that. But that's what's controlling the speeds of it, and these wires create a resistance a voltage drop to slow the blower motor down. Newer styles of these could look like something like this. This is a credit card style resistor, but this would also be a 4-speed resistor. If you have a system like this, which is an automatic temperature control, which I have unlimited speeds, you know, I have 14 different speeds here on this particular unit, but I could have 24 or 44, or I can't really feel the changes. The knob just turns around in circles forever, you know. Well, then you probably have some type of electronic relay. This is called, sometimes called a power module, but we're pulse width modulating voltage to the blower motor to control the speed. And so that's a whole nother subject matter when we start getting into the electronics of the HVAC assembly. This is kind of just talking about airflow for right now. So it's going through the inlet door, going through the blower motor. It's going by the blower motor resistor. The blower motor resistor has to be in the airflow because this is going to get hot, and so we want to keep this cool. If this thing is dropping, if this thing, someone unbolted it and it's hanging down by the passenger feet and you run it, it's probably going to heat up and damage because, again, that airflow is there to try to get rid of the heat out of the resistor. But the next device that it goes through, you can kind of see this big old section right there, is my evaporator. So the key here is that all air goes through the evaporator all the time. I don't care if it's on hot, if it's on cold, it doesn't matter. If I have that blower motor on, all air goes through the evaporator all the time. Because I could have the blower motor, so I could have the AC on when I'm on full cold, obviously, but also if I'm on full hot and if I have it on defrost, my mode position, well, I'm gonna probably get that air conditioning to kick on in order to remove the humidity, so I'm not fogging up the inside of the windshields. So all air goes through the evaporator all the time. So this middle section here is the temperature section, because after the evaporator, the air is going to go through the heater core, and so I got the heater core right here, and I got a door. And a door is going to move sideways back and forth in order to allow either air to be routed around the heater core or through the heater core. So we call that the temperature door, or we call that the blend air door. And so, you know, the middle section is typically where we're controlling temperature. So if I go to full hot, then my blend air door is going to be routed to where all the air goes through the evaporator, it goes through the heater core, then it comes out of the outlet ducts. If I go to full cold, like that, well, that blend air door is going to move and it's going to block the airflow going through the heater core, and all the air is going to go bypassing it out of the outlet ducts. And so again, I got a actuator, electronic actuator, another actuator that's on the bottom of this particular unit. It's up at the bottom, and I have a one here that I have the same system, but I can kind of see that I have an actuator on the bottom of that thing. So you can see the actuator, the white actuator on the bottom of that. And the actuator on the bottom of it is what's controlling the door. And try to hold that up here like this. So I can see this actuator right there. So that actuator is my door. And I can see that my door would be sitting right here in this position right in here. And so that door is going to be positioned in that door right there. Here's where my heater core is going to be on the bottom of this unit. Oh, I have this upside down. I wanted to point out, my drain tube. So the drain tube sits under the evaporator, and that's important because when the AC is on and all that condensation is accumulating around the outside of the evaporator, that water has to go somewhere, and so it's routed at this drain tube, and it hopefully is going to be dripping outside the vehicle. And the key is that this gets plugged up on a hot, humid day. The evaporator housing could get filled full of water and start making gurgling sounds and leaking on the floor and stuff like that. So on a hot, humid day, all that water you see dripping out of your car is all that condensation on the evaporator coming out, and it's routed out there. And there's not much else I can see on the bottom of this. Oh, I'm gonna lift this up just a little bit so I can see, but I do have my blower motor resistor right there, which on this unit would be sticking right up under there. Okay, next is the outlet section. So the outlet section on this, you typically have three main positions in which air is going to come out. You're going to have air coming out of the defrost vents, you're going to have air coming out of the panel vents, and you're going to have air coming out of the floor vents. And so if I take a look at this position right here, on this knob right here, you typically have 1, 2, 3, 4, 5 main positions. And so in order to get 5 main positions out of 3 main levels, we'll call that defrost, panel, and floor, you typically have 2 doors. 2 doors that are somehow working together in this outlet section in order to get air to come out in through section. So I got my panel section. We'll say that this could be our panel section right here, where air is going to come out of the outlet door, sometimes called the mode doors. And then I got going to my panel section and my floor section. Well, that's called the bi-level position, is the old term for that. They used to have words on these. Now they have hieroglyphics because nobody knew what bi-level meant. So if they put a picture in there, well, now they don't have to translate that to Chinese or something like that if they're going to ship this car around the world. But of course, these two doors are going to have to move somewhat in a sequence of events in order to make that happen. Then I got the floor position. Air is going to come out probably at the bottom down here somewhere. Then I got the defrost and the floor position, which, on a cold day, you're trying to get all the ice out of the windmills, but your feet are kind of cold. So that's a good position when it's negative 15 degrees here in Kansas, like it was the last couple of days. But that's called the mixed position. And then I have the defrost position where it's just coming out of the defrost vents above the dash. The key here is that this particular unit only has one actuator. So that one actuator is over here. Oh, there it is right there. It's right here in front. So there's the actuator right there in front. And it's controlling one door. I see one door here and I see one door there. So I can see those two doors right there. So in order for one actuator to control two physical doors, well, you have to have a cam mechanism, you have to have levers, you have to have some type of synchronization to where as that motor rotates, because it rotates in a circle, you create a rotary motion into linear motion in order to get these doors to open and close. And the rough thing about HVAC systems is that when you take every single car out there, every single car has a different HVAC system. So if you take one Suburban from one year to another one, it may share something, it may not. But typically this is built for a particular vehicle and you have more than one type. So it could be that on manual AC system it's built one way, but if the option goes to automatic or dual zone, then it's different. It's not exactly the same. And so you literally have hundreds and hundreds and hundreds and hundreds and hundreds, probably into thousands of different HVAC assemblies as far as how they're actually configured. But basically, airflow is the same, where you have the inlet section, and air is going through the temperature section, then it comes out of the mode door through the outlet. This is the section of the HVAC assembly that is towards the bulkhead. So you can see that you have your H valve that's going to stick through the bulkhead where your AC lines are going to be connected to. You have your heater lines, so your two heater hoses are going to be connected to your heater core. The heater core is on the top, so unfortunately in order to get this heater core out on this particular vehicle, you're going to have to remove this section from the dash because the dash is sitting right on top of this. In order to get the evaporator out, which sticks into this section right here, this is called a clamshell design, where I have to physically undo all the bolts along the side of this, and I take the top half off and the bottom half off, and the evaporator sits in the side. So I tell students, one of the most time-consuming things that you can do on a car, on a lot of cars, is replace the evaporator, because that, you're pulling the dash out, you're pulling the HVAC assembly out, you're splitting the HV assembly out and replacing it. Of course, you got to remove refrigerant, and so again, that's a pretty labor-intensive repair when you start looking at 12, 13, 15 hours for a repair of an evaporator. So if you go back a few years, I would expect that modern air conditioning systems all have electronic actuators, because they're probably more going to a dual zone. They have electronic, instead of having a temperature slider, they have a temperature knob that says 70, 71, 72, 73, or whatever. But if you did have an older, what I'm going to call a manual system, you could have these doors that are set up with a vacuum. So here I have an example of a vacuum pod, and this looks like it could be my inlet door is what it could be. But what I like about the vacuum pods is I could physically come in here and I could actually move these doors by hand. If I stick my hand up in there and move them, I could apply vacuum to one of these pods and get them to move. But it's kind of a nice thing to be able to do on that. So I got two vacuum pods on this one over here for one door that's inside here that it's hard to see, but then I got this vacuum pod right here. And typically if you have more than one vacuum line going in there, then it could have more than one position. So it could have an intermediate position, and it could have a fully closed position on that. If I try to move these doors on this electrical unit, well, I'm going to break something because it's physically connected to that actuator, that electronic actuator, and I can't move it. If I try moving this, it's going to break. So I talked about two ways you can move one of your doors. One is electric actuator, one is through a vacuum pod. The third way we can move a door is cable. So this is an older system that you can kind of take a look at the control head on it, but it looks like my recirculation door. If I move it that way, you can see a cable right here moving, and the cable is connected. A Bowden cable is what that's called, but over here it's going over to the recirculation door. This guy right here is my temp door, so if I move my temperature door, I can physically get, again, I can see the cable right there move. Is my temperature door, which is inside, is moving back and forth. What's kind of unique about this system is that my recirculation door and my temperature door is cable driven, but if I look at my mode door, so there's my mode system right there. Well, my mode system is electronic. So if I take a look over here on this side, I have a electric actuator, and underneath the electric actuator is a cam mechanism, and that cam mechanism is moving multiple doors in there as this actuator moves. So you could have an HVAC system that some doors are operating cable, some is operating electric, or it could be electric and vacuum, or it could be vacuum and cable, you know. So I've seen all different mix and matches. I've seen one that was cable, vacuum, and electric. So all three doors, we'll call that your mode door, or your temperature door, or your inlet door, recirc door, you know, all three a different style as far as movement on that. So that just depends on the engineering as far as how they design this. If you have a real rear AC system that has a rear, you know, HVAC system in the back, then, you know, looks something similar to this. Typically they're in the quarter panels, could be the driver's side quarter panel, could be the passenger side quarter panel. But what's different about the rear HVAC assembly, you know, it has almost everything it does that a front one does. It has a separate blower motor, has a separate heater core, has a separate evaporator, it has an H valve in it. So if all my AC lines up, it has an H valve in it. There's my H valve right here, so H valve in it. It has two actuator systems, not necessary three. So you have to remember that on a rear AC system, all air coming into this is inside air, or so it is recirculating air. It's not getting fresh air from outside the vehicle. So it does not need an inlet door, but it does need a temp door, and it does need a mode door. So again, for hot or cold, you know, I'm going to route air either around the heater core or through the heater core. And then if I want air coming out of the roof area for air conditioning, well, then that door has to move. Or if I want hot air coming out at my feet, then that mode door has to move. And so just be aware of that these units are sometimes easier to get to, because all I got to do is take out maybe a back seat and a rear quarter panel, and you can pretty much see this whole entire thing sitting bolted to the quarter panel of the vehicle, versus, again, a front system, it's a lot harder to see. Here I can see my heater core right here. So on this particular unit, fairly easy to get out, you know, not so bad. I do have some gearing in here for my mode actuator, but again, nothing real complex. So again, these rear units, again, are just mini versions of the front, a little bit easier to figure out. Here I have my blower motor resistor to control the fan speed. Here I can see my squirrel cage, where air is being pulled in. So air is going to be pulled in right through this hole right here, which is typically going to face towards the outside of the vehicle. So you don't normally see this, and you know that. So that's something that you can't normally see while sitting in a car. Typically this side right here would be the side that you would see when you take the interior quarter panel off, and so you can kind of take a look at all your items here. Here's another example of an HVAC assembly that is a little bit more complex. If I take a look at the end of this particular unit, this is the end that would be over by the driver's the driver's feet, kind of where the accelerator pedal is. I have three actuators, and underneath these actuators are mini gears many clogs and levers, and so when you start getting into this, I tell students or technicians that you may want to take some pictures as you're taking it apart, because these all have to be timed. And if you take a part in order to replace a door or a gear or a lever or even an actuator, that's very easy to get things mixed up and not together. So they get very complex as far as the timing on this. This particular system is dual zone. So the dual zone, it actually has an extra actuator. It will have 2 temperature actuators, not just one. It will have a temperature actuator for the driver's side and a temperature actuator for the passenger side. So just be aware that it could have 2 actuators in there. Also for the mode door, it could be that I gave an example of one actuator that was cammed and geared in order to control multiple doors, mode outlet doors. But you could have one actuator for each individual mode door. They could have at least 2. They could have 3, they could have 4, they could have 5. It could be very complex as far as the airflow out of there. And so just be aware that minimum you would have, I would say, 3 actuators: inlet, temp, and outlet. But if you have dual zone, well, that's going to give you an extra one. If you have a mode system that someone designed it where, hey, I want to put more actuators and less gearing in it, well, then all of a sudden you could have more than one outlet door. You could have 2 of them, you could have 3 of them as far as actuators itself. So again, the word to the wise is take lots of photographs of these as you're coming apart, because the service manual may or may not give you good information and good pictures that you can see to get it back together again once you have it apart. This is Scott Norman, and if you're looking for more automotive educational videos, please subscribe to my Professor Pintang YouTube channel. Thank you very much, and I hope you enjoyed the video.